So taking the integral of parametric equations is a little bit different from doing a normal equation. You got x and y here. Let's go ahead and take a look at our area equation. So usually you do an integral from, say, whatever x1 all the way to the final x. And you'd be doing this from 0 to x here with your function, I guess, and y function here. And then there would probably be a dx there. It kind of makes sense, right? But in this particular case, we're going to change this around. For our parametric equations, we're going to go 0 to t. And this time, it's weird. So you know how you got a y and you have an x. So depending on whether you're doing this across the x-axis, in which case you would use yeah, it's going to be very similar to this. You would use y, which is this. But then you also have to add in dx over dt. And then you can take the integral over dt. So it's kind of weird. So this is for the x-axis. And then for the y-axis, let's say you were going to do for y, 0 to t, you just use x, and then dy over dt. And then now you can integrate. In this case, we're going to be using the x-axis here. So let's go and try this out. All we really have to do is just say a equals the integral from 0 to ln of 9, plug in the y, which is going to be 1/5 e to the negative t third, and then take the derivative of x. Well, let's just say it was e to the x. I'm sure this is easy enough to do. It's going to be 5e to the 5t. Awesome. And now we could take the dt here. Simplifying this, keep note that those will cancel, and then we're going to get e to the 5t over e to the 3t. Simplify down to e to the 2t. This should be an easy integral as well. I believe that's just going to be e to the 2t divided by 2. And then now we can go ahead and go from e to 0 to ln of 9. And as we know, it's sort of more like e to the ln of 9 squared. This can cancel out, and then you'd be left with minus 1 on the other side. And 1/2, sorry. Keep note that this is over 2 minus 1/2. So I guess the total is 80 over 2, which is 40. Interesting. Okay. So anyway, this is the important part, is understanding the formula for an area of the integral here for a area under the curve parametric equations.